In this lesson, I'll show you how to integrate definite integrals of simple functions. I have already done a video on how to integrate indefinite integrals of simple functions. There's a difference between the two. A definite integral is finding the antiderivative of a function with a lower and upper bound. So the end result is a number, and that number represents the area underneath that particular curve. Whereas an indefinite integral is when you don't find an area. Instead, you find a function that represents the area of any bound that you could choose if you'd like. Now, this video caters to students who are new to integration or need a quick refresher. And if you hear me say the word antiderivative or integral, they are synonymous, so they mean the same thing. Let's start with question 1. In question 1, they want us to find the integral of x to the power of 2 dx between 2 and 4. The lower bound is 2, the upper bound is 4. We first find the antiderivative of this function, and then we use this formula to find the definite integral. Here's what I mean. The integral of x to the power of 2, we simply add 1 to the exponent, and the sum of that we divide by the function, or by the term in this case. So we have x to the power of 3 over 3. The sum was 3, so I divided by 3. And instead of putting plus c as we usually do for indefinite integrals, this time we have to evaluate this function at 4 and 2. We evaluate the upper limit minus the lower limit. So I'm going to evaluate at x is equal to 4 minus when x is equal to 2. Let's start over here. 4 to the power of 3 is 64. Divided by 3, that doesn't reduce, so I'll just write down 64 over 3 minus 2 to the power of 3 is 8, divided by 3 is 8 over 3. The denominators are the same. So 64 minus 8 is 56. And that number represents the area for this curve between 2 and 4. Let's move on to question 2. To find the integral of this function, we have to use u substitution. I'll set this part equal to u and take its derivative. U is equal to 2x minus 5. Taking the derivative of this, we end up with du is equal to 2 dx. Solve for dx. Du over 2 is equal to dx. So I have the integral between 0 and 3 for u to the power of 3 du over 2. I replace this with u, and I replace this with du over 2. Next, I'll take the integral of u to the power of 3. And before I do that, I can actually pull out this 1 over 2 outside. That way it doesn't bother us later on. 1 over 2, introduce square brackets. U to the power of 3 becomes u to the power of 4 over 4. Now that I've done that, I can also take out this quarter. That way it doesn't bother us as well. Leaving us with 1 over 2 times 1 over 4. U to the power of 4, that can be replaced back with what I set it as originally. And what I set it as was 2x minus 5. 2x minus 5 to the power of 4. Now I have to evaluate this at the upper and lower bound. I have 1 over 8, square brackets, 2x minus 5 to the power of 4 when x is equal to 3 minus 2x minus 5 to the power of 4 when x is equal to 0. 2 times 3 is 6 minus 5 is 1 to the power of 4 is 1. And 2 times 0 is 0 minus 5 to the power of 4. Negative 5 to the power of 4 is 625. So we have 1 minus 625 times 1 over 8. Let's use our calculator. 1 minus 625 divided by 8 gives us negative 78. That is the area for this curve between 0 and 3. Let's move on to question 3. In question 3, they ask us to integrate between negative 3 and negative 2 for the function 1 over x. To do this problem, we will be using the following relationship where the derivative of 1 over x is simply ln absolute of x plus c. That's the indefinite integral. So I'm going to use ln x for this. The integral of 1 over x is ln absolute of x. And now I'll evaluate this at x is equal to -2 minus ln absolute of x at x is equal to -3. I'm going to use my calculator for this. Ln, and the absolute of -2 is 2, minus ln when x is 3. The absolute of -3 is 3. This gives us -0.4054. -0.4054. In question number 4, while it does look very similar to question 3, it's actually a tricky question. Because if we find the integral of 1 over x, remember it's identical to this, we end up with ln absolute of x plus c. However, if you graph ln at x, and the graph is shown on the screen right now, you'll notice that it is discontinuous when x is equal to 0. So we are asked to find the integral between -3 and 2. But you can't find the area between -3 and 2 because it's discontinuous at x is equal to 0. Therefore, be sure your function is continuous and differentiable between the given limits before evaluating a definite integral. So the answer to this question is undefined. There you have it. 4 examples on how to integrate definite integrals of simple functions.